Okay, so I will share my screen. Boom. All right, so we're talking about making sense of other people's code. And I'm trying to remember where we were at. Talked about how basically you spend at least half your time reading code with the work that you do, and there's many reasons why code can be hard to read. And this is our reference book and our model of our brain. We've got the information comes in, goes through a filter, goes into your short-term memory, and there goes to your working memory. Each of those is about there's like a 30-second limit on the stuff that stays in your short-term memory. And you got 3 to 9 things that you can keep in there at any given time. Same thing with your working memory, and then it gets associated with something in your long-term memory. And so that's how you are able to keep remembering things. The 3 kinds of confusion: lack of knowledge, something, you're just completely unfamiliar with something; lack of information, you're just, you don't know enough about it; and then finally, lack of processing power. There's just too much to do and your brain gets overloaded. Okay, so we did this stuff. We saw the cool CodeGlance Pro. We learned about design patterns. It's a way of chunking things. Comments are a way of setting beacons. And so we can use this information to help us to be able to understand things more quickly. And so all of that being said, all of this is basically stuff, ways to remember stuff. I think this is where we stopped last time. I don't remember. So, the question is, what about Google? I thought that was supposed to keep us from having to remember everything. And the point is that the more you learn, the faster it is to learn other things, because you've got more things in your long-term memory to associate things with. If you stop to look something up, it breaks the flow, of what you're doing. And so you've got to then get back into the flow, and that takes time. If you get distracted, I don't know about you, but a lot of times when I'm looking something up online, I will notice something very interesting that takes me off in a totally different direction. And an hour and a half later, I'm like, oh yeah, I was working on this work problem. And instead I've been reading about the coronation and, wars going on, interesting problems with the movie stars. And it's like, okay, it takes you on average 15 minutes to get back to where you were. I'd say that's on a good day.
Let me tell you, Scott, my brain is like that. Yeah. If something happens and it's like I get distracted, it's like my brain goes and I lose like 20 minutes browsing something, and I get a lot of distraction. That's the reason I started to use the Pomodoro technique in order to focus in one task and only one task, because in some interviews, some people ask me, can you handle multitask? And I can tell you that I don't know if it is the right answer, but I cannot handle multitask. I need to be concentrated in one task. I can do many tasks along the day, but I need to be concentrated in one task and one task alone. Right. And I use the Pomodoro technique to focus on 25 minutes in one task in particular, but no distractions at all. No cell phones, nothing. And I can tell you, it has helped me a lot to focus my brain. And because I tend to get so many distractions, and it's hard for me. Yes.
Yeah, I can multitask very poorly. But yeah, multitasking it's a myth. You can't really do that. Your brain you can focus on one thing at a time.
Yes.
And it's the task switching is the hardest part. So all that being said, there is, when you remember something, there's a decay. When you first learn something, your brain decays, and by the end of the day, you've forgotten like 40% of it. By the next day, forgotten 80% of it, and it goes on from there. But if you go and you repeat it, you effectively relearn it, then you'll remember more of it at the end of the day, dramatically more. And basically this rate of decay is, if you can take advantage of that by reviewing the information that you've learned on a regular basis, ideally it's like, 1 day and then 3 days and 6 days. If you can do that, then you have a much better chance of remembering things long term. This is called spaced repetition, and there are a couple of tools that help you to do that. This Anki app is one that, see, I had this up and running, but I don't have it up and running right now. The computer rebooted itself. So, but basically, these are flashcard apps that will show you some information here. I'll just go ahead and run it real quick. But basically, it's a flashcard app. It'll like show you a question and then show you the answer on the other side. So, and since there are a lot of software developers trying to learn a lot of things, chances are good that the thing you want to learn is already created in a book.
Awesome. So, yeah, 100 devs. I heard 100 devs in a podcast. Yeah.
Yeah. So if you're wanting to learn Git, I haven't started this one yet. What is a branch? Well,
okay.
A branch is when you take the code and make a copy of it to work on it outside of the original branch, which is really a bad answer. Let's see what we have here. Branches allow you to develop features, fix bugs, safely experiment with new ideas in contained area of your repository. Okay.
Awesome.
And so basically, by reviewing this sort of information, you can remember things.
Yeah, I will totally install it.
Now, one thing that's important is that you need to practice the remembering. We have two different kinds of strengths in our memory. There's a storage strength, which is that the things in our memory tend to stay there, and the retrieval strength, which is effectively our ability to recall what we've already stored in our memory. I'm sure that that you have forgotten your phone number at some point. It's not like you don't know what your phone number is. It's just that, it was there and I can't remember what it is. I can't recall it right now. So, like you saw when I asked the question, and then I went back and after I tried to answer it, I went and then looked at the answer. That's really what you need to do, is to try and remember the answer before you flip over that card, or before you start to look it up on Google, because by going through the exercise of trying to remember something, you will strengthen that ability to recall things. Okay?
Mm-hmm.
At home, I store things for quick retrieval because I want to be able to find them quickly, which means that I have piles of stuff all over the place. Drives my wife crazy. She likes to store things for not having to see them. So she doesn't care where they are. She just goes and stuffs it into a drawer, into a closet.
Uh-huh.
Consequently, she can never find anything. So she called me because I'm
Uh-huh.
good at finding things because I'm always looking for stuff because it's in one of these piles.
Mhm.
But I'm skilled at retrieving things. But in the same way, you can develop the skill of recalling things by practicing
Uh-huh.
recalling things, and that's how you
Awesome.
build that retrieval strength. Okay, because I mean, the stuff that goes in your brain generally stays there. All right, so there's another concept called elaboration, where we don't necessarily remember things exactly as they are. You know, that in that model of our brain, there's a filter that of things that come in. So it's the things that we remember could be filtered by how we're feeling that day, or
Mhm.
experiences, or our personal or cultural background. Whatever details could be altered or forgotten. You know, picture here the shorthorn cow or the longhorn cow. I don't remember which. I know it was a cow. So elaboration is the idea of thinking about what you want to remember and relating
Mhm.
it to an existing memory, and make the long-term memory fit into your make the long-term memory be, you know, what it was, and make sure you get the important details down. All right, so let's
Yeah.
consider.
Can
Yeah,
I make a comment of the last slide?
absolutely.
I watched a documentary. I will try to search and send it to you. I
Mhm.
watched a documentary about how you remember how many people can remember a particular event in many different ways,
Right.
like you say on elaboration, because and it was this particular event was the 9/11 event in New York,
Yes.
and many people remember differently, and
Right.
it because and each one they they were swearing that it was like that, but it was different,
Yes.
and it was really interesting. So I will try to search and find it and send it to you.
Yeah, I saw a report one time where these people basically they interviewed a number of people shortly after the 9/11 event, and said, you know, what happened, and then interviewed them, I think about 10 years later, and asked them what happened, and their memories were different. And I don't know what I was thinking back then, but that's clearly not what happened. Oh, you think you remember better 10 years later? I don't think so.
I believe it's the same. I believe it's the
Oh,
same.
okay, could
The
be.
one that
Yeah.
we watched. Yeah,
It's
because
fascinating.
it was really, yes, it was really interesting how many people change the events. But
Yes,
as you say, it depends on how you feel, you know.
right. Yeah,
So it's like, and you know, in your life, you also have these moments like you say, I remember it was exactly like this, and it was, but maybe it wasn't because our memory tends to forget some details, you
right.
know, and to add some others that weren't true. So
Hmm.
yes,
Yeah, and
it's
also,
really interesting.
you know, I like to, for instance, go to a technical conference with somebody so that afterwards we can discuss the session we went to, because they remember a number of things very differently than I remember. And so
Mm-hmm.
we can combine those memories together. It can be much more useful. So, but that's just the nature of our memories. They don't necessarily
Yes,
stay the same.
yes.
So, so let's consider that you want to remember some new concept. Like, for instance, here I've got this is comprehension in Python. Um, a comprehension is basically, you know, a way to take to generate an array and do an operation on each member of the array.
Mm-hmm.
You know, have that array generate. Okay, um, So we want to make sure we remember how to do this correctly so that we can write it correctly or at least recognize it when we're reading it. So first we think, what does this concept make me think of? And I write down all the related concepts. I think of, it's sort of like a loop inside an array, and it makes me think of, there isn't anything equivalent to this in Java. But I mean, there's different things that it can make me think of. Next, for every related concept, think, okay, what does this new concept, I'm sorry, why does this new concept make me think of these other concepts that I already know? Does it share a syntax with something in another language? Is it used in a similar context, or maybe this new concept is an alternative to one that I already know? I already know how to do a loop, and I already know how to do an operation. So this is sort of just combining them into a more succinct way of doing it. All right, so what other ways do you know to write code to achieve this same goal? So, and try to create as many variants of that code snippet as you can. So, like, are there other programming languages that have a similar concept? I mean, how would we do this in like Clojure, or how can we do this sort of thing in C#? Can you write down examples from other languages that do the same thing? How does their syntax differ from how we do it in Python? And then, does this concept fit a certain paradigm? Or maybe it's part of a domain or a library or framework or something. Where does this shoot, I forgot what it's called already. Where does this syntax fit in our in, I guess, the general scheme of array generators, that sort of thing? Man, it's early in the morning. My brain is not working. So
we need coffee. I'm drinking apple with oats.
There you go. Yeah,
so yeah, my brain needed.
Okay, so we learned about how to improve our ability to read code that we don't understand. So what about code that's too hard or too complex to figure out? Okay, so we have our short-term memory, and that helps us to remember things by sending it through the working memory to the long-term memory, right? And associating it there. So this working memory is used for processing the information in our short-term memory, right? And the working memory processes about 2 to 6 things at a time, more than that, and we get cognitive overload, which is, we can hold 2 to 6 things at a time for about 30 seconds in our short-term memory, and the working memory. So you see how this is really our limit.
Yes.
So basically, there are 3 different types of cognitive load. So you've got intrinsic load, which is how complex the problem is in its nature. There's extraneous load, which is, what other distractions are there that make the problem harder to understand. Then there's a germane load, which is the work that you have to do to take your thoughts and store them into long-term memory. All right, so for example, if you're calculating a least squares algorithm, the intrinsic load is, the basic formula to draw the line that we want. And then the extraneous load is the intermediate variables that that we create here, and then the methods that we call to do the calculations and whatever the special syntax is that we might use. And then the extraneous load, I'm sorry, the germane load is finding a way to filter through all this and condense it down to the essential parts so I can associate it with the long-term memory so that I can recall it correctly later. Okay, so we'll do an exercise of reading some unfamiliar code. And I've got some code here. And notice when you feel the need to take notes or take smaller steps, what kind of cognitive load are you experiencing? See, we're filling some arrays here with some values. Got a big for loop here, and then another loop here, 2 loops inside the big loop. And then variables that we're storing stuff in. We got these little 1-letter variables. I guess they're counters, which makes it really hard to keep track of them. We want to record that. So this would be the extraneous load is those little variables I got to keep track of. The intrinsic load would be the loops, the whole calculation. So this is our the MST, says the minimum spanning tree if you're going through
okay. Yeah, my brain was like, what? But this is Java, for example. This is Java.
Yes, this is Java.
Okay, yeah. Right now my brain is like, I have a filter in the model that you show me, like when you have information, you have a filter.
Right.
Perhaps a filter could be like, for example, in my mind, for me, I'm always thinking like Java is too difficult for me. I will never learn it. It could be that could that be a filter or a prejudice?
Yeah, that can be a filter that makes it harder to learn.
Okay. So yeah, but I was reading this and I was okay, it is Java, but I thinking mathematically, I think this is a matrix or something. So my brain starts to relating matrix operations. I'm beginning to bring knowledge of my mathematical background in matrix. So I started to this is how it's working, and because you have to force, you are starting to working on each one of the matrix levels.
Right.
So my brain starts to working like, oh, okay, I'm going to play this. But I really don't understand the extraneous cognitive load type. What outside distractions add to the problem? What could be extraneous in this code?
Oh, for instance, in here, basically you've got I and U and V we have to keep track of, and then we go and fiddle with U here in the middle. What is U? U is a counter. I've got U sub U, and so I've got 2 indexes into 2 arrays. This can be confusing. And you're going and you're reusing V down here because you got the loop for V here and this V. That can be really confusing. So that's an extraneous load. So the intrinsic load is like, okay, I've got to go traverse the tree to figure out how to walk through it so I can find the shortest route through the minimum spanning tree. And so that's And this is just an implementation of it using loops.
Mm-hmm.
Okay, does that make
Mm-hmm.
sense?
Yeah, totally.
Okay, so basically, what are the steps that we would use to
Mm-hmm.
cognitive load of a complex algorithm that we're looking at? So the most obvious thing you can do is to refactor it. So refactoring is changing the structure of a program without changing the behavior. You can refactor to make the code more maintainable by breaking out a number of reusable methods, but that sometimes makes it less readable. So when you do cognitive refactoring, you're going to want to make it more readable. So you may well do some reverse refactoring. We also call that inlining, where basically you take code that you've broken off into a method and you just inline it into the original code, and you can duplicate it, so you can just read it line by line from top to bottom. I I call this a temporary refactoring, where basically you're going to go and reformat the code. You're not necessarily going to keep those changes. You go and you reformat it to read through it, and maybe you can rename variables along the way and do that sort of thing. But when you're done, you just go and revert it back to how it was, so that you don't have to worry about you might have broken something in the meantime. And at this point, you're not really trying to fix something, you're just trying to understand it. Okay.
Mm-hmm.
Another thing you can do is you can take unfamiliar language constructs and replace them with more familiar language constructs. Like in Python, we had that new construct that we were unfamiliar with, and we're trying to learn it. And you can just go and replace that with a couple of loops. Lambdas can be confusing to people who are unfamiliar with Java. So you can go and you can replace that with anonymous functions and that sort of thing. Even ternary operators with, that's the if statement with the question mark.
Mm-hmm. Mm-hmm.
So
Mm-hmm.
that can be confusing to read. Turn that into an if statement.
Mm-hmm.
So, of course, readability is in the eye of the beholder. If you're very familiar with these concepts, then you can read them easily, then then shouldn't be a problem. But you do what you have to do for your own understanding, and any changes that you make are going to be temporary, and you can always roll back to how it was when you started.
Okay.
Now,
I love the phrase that you told me. Unfamiliarity is in the eye of the beholder.
yes,
Nice.
yes, and of course, if you do find yourself expanding out unfamiliar language constructs, this is a good signal that we need to spend some time learning it. So
Yes.
I think, a 10x developer works on code faster because he has all of this knowledge in his brain, instant recall. And so by using the skills we've talked about here, you can grow your knowledge base and then grow your skill base surprisingly quickly.
Mm-hmm.
And you take the things that you don't know well, create a flashcard so you can build up your long-term memory.
Exactly.
Okay, so there are helpful tools that we can use to externalize the parts of our brains that get overloaded. Okay, we'll talk about dependency graphs and state tables, how you can create those and use and combine them in looking at code. So a dependency graph is basically you can mark the variables that you have, and you can connect related functions. This is an online tool that Felina Hermans has created in her Code reading.club's website. And so, yeah, you can just go and highlight different variables so you can keep track of where they're used throughout the program, and you can relate different things to each other. You can also print stuff out, and that's what I generally like to do, print it out and use a highlighter and pencils to compare things and relate things and see how the loops are related and that sort of thing.
Awesome.
Then you've got your shoot, what was that thing called? The state table.
The state table.
So basically, that's just keeping track of the different variables, and you write down the initial value of each, and then the first time through the loop, you can write down how each variable is changed, and next time through the loop, how each variable is changed. So you can take the time to go and walk through, see how variables change. And of course, you can use your debugger to make this easier. But writing things down tends to help you remember things better. So it helps you get more clarity more quickly. And of course, you can combine these dependency graphs and state tables when you do this by hand, printing things out, and that will increase your depth of understanding for this unfamiliar code you're trying to understand. So these are ways to sort of take your brain and externalize it onto something else. Since you can only cram little bits in your brain, you can break it up and create chunks that are meaningful in an external way. Okay, so some other tools that we can use. We use our IDE. It has that built-in syntax coloring, and it'll show you how lines are indented, and plugins like that. CodeScene, whatever the thing that I talked about earlier. What was that called? CodeGlance. That plugin for
yes.
IntelliJ. Of course, you can always fall back on paper and pens, printing things out, highlighters. Your debugger, you can use that to do things. You can set a conditional breakpoint. I don't know if you've seen how to do that. You can we got to get something here. Set a breakpoint here. You can right click on that. You can set a condition. So I can say, okay, whenever this charset name dot equals food, then it'll stop every time that charset name is food. Otherwise, it'll just continue to run, so you can get to that debugging point more quickly. You can use your profiler, so you can see the call stacks you get to when you're at something. Your debugger can also help you keep track of your call stacks as you're working through. And then tried and true log files. You can print stuff out, print statements as you're working through the code to see how things work. So these are all helpful tools that have been developed over time for us developers to make it easier to understand unfamiliar code. There is a new book that came out a few months ago called Troubleshooting Java, by guessing it's pronounced Laurentius Spilka, but I just
yes.
guess. Okay. I mention it here because frankly, the main reason we find ourselves reading unfamiliar code is to find a problem in the code and fix it. And this book is a terrific resource to help you use the tools that are available, and
Awesome.
especially for Java, help you minimize the time that it takes you to track down the source of a problem. I enjoy tinkering around the house, but it'll take me half a day to, hang a door or paint the fence or something like that. When I hire someone who does it professionally, they get the job done in 30 minutes. And they have to, because they have to get on to the next job right away. You can't waste time tinkering around and running to Home Depot 5 times for the thing that they forgot. This book, along with the skills that we've talked about, will help make you a professional developer. Excuse me. Because it'll minimize the time that you waste trying to understand code and ultimately finding and fixing the problems that you need to in it. So we're working on making you as close to that 10x developer that you're aspiring to be. Okay. So in summary, what we've talked about, there are 3 kinds of confusion: lack of knowledge, lack of information, lack of processing power. I don't know anything about it. I don't know enough about it, or I can't keep it all stuffed in my brain. 3 ways to overcome the kind of confusion: add information to your long-term memory by going through using the flashcard tools. Increase your retrieval strength by practicing remembering stuff through the flashcard tools, and then reduce your cognitive load by mastering the tools that you have to break up the problem into rememberable, easier to remember chunks. So yeah, it's making things into small enough chunks that we can fit them into our brain. Okay, so my challenge to you is to either start or join a code reading club. Maybe you can start one at with your geek friends or your friends at the office that you work with, and you can practice reading code. You can go to the codereading.club website, and there Felina has a list of different code reading clubs around the world that people who are practicing reading code. Also, she hosts a code reading club once a month, and you can join in on that. And it's where I've learned a lot of the cool things that the tools that she has and stuff. Also, awesome. There's a site called Awesome Legacy Code that's hosted by this company, Legacy Code Rocks. Excuse me. You can read all kinds of cool code, like the original. Let's see, do I have that? Oh gosh, I did have it up. Let me just bring it up real quick here. We go to here it is. Come on, help me out here. So basically, various languages. You can look at the Apollo 11 guidance computer.
Wow.
There's a couple of videos that walk you through how that works. The Prince of Persia from Apple II.
Wow.
Look at the first versions of MS-DOS, Microsoft GW Basic. You can look at Wolfenstein 3D or Doom. Wait, so these are some cool games. See the original web browser, Netscape Navigator. You can see the NASA structure analysis tool. In Fortran, you can see the original Adobe Photoshop. All kinds of cool stuff. Other things that you could do is you could look through the Java, what do you call it? the JDK code. When you're in your development program, say you want to see what string, how that's defined, you can go to the just do a control click on this, and you'll go to the definition, and it'll bring up, here's what string looks like.
Mm-hmm.
And this is the code that they wrote to implement string, and you can find out all kinds of interesting things, like what stuff is deprecated. You can have a string of bytes with an offset and a length, so you can get a substring from a bunch of bytes. What is this? You're going to initialize a string from a char set, so it's got to go and figure out what kind of character set it's using. So look at all this code to go and create a string from a character set. That's amazing. So anyhow, you can go through and figure out, how the language works in this way. If you arrays, what does arrays do? That is that was created in Java 1.2, and it's got a whole bunch of different things. It's got the ability to sort arrays. It's got and parallel sort, and that uses a dual pivot quick sort. I had no idea that even existed. So let's dig into that. So you spent all day digging through the code.
Mm-hmm.
So basically, that's what I have for you. I think you've seen my Code Smells book, How to Get a Hold of Me. And so go read you some code.
Okay. Okay, you have also a website, keepcalm@refactor.com.
I beg your pardon?
Yeah. No, yeah. I was searching for your book.
My what?
Your book is Code Smells, right?
I wrote this low-hanging Code Smells.
Okay.
Have you seen that?
No, I haven't.
Oh, I'm so sorry. Yeah. So basically, I've written and I talked about how you can't write readable code unless you can recognize poor code. You can't recognize bad code if you don't know how to do it. So basically, I've written a book it's a little short ebook that lists some of the most common code smells and how to refactor them. And
awesome.
You grab the book, you can get on my my email list. I'll send you a regular whatever little message about refactoring and interesting stuff to learn. So
awesome.
There you go.
Okay, cool.
All right. So that's what we have. And
awesome.
Any comments or questions or concerns?
No, I just took a bunch of notes and I will review the concepts. What really caught my today, it was the cognitive load types.
Mm-hmm.
I will try to go deeper on those concepts, and try to grasp a little more about this. But it's awesome. I'm very excited to learning. Yes.
Very good. I'm glad. All right. Well, then I will go ahead and stop the recording.
Yes.
We will end it for now.